Hello and welcome to the second part of Lesson 3.6. We're still looking at equations and problem solving. So I'd like you to try to do example 6 on your own. This is similar to what we did examples 4 and 5. But it says an airplane left an airport at noon flying at 180 miles an hour. And it did say at noon here. A jet that flies at 330 miles per hour left the same airport at 1:30. The jet follows the same route as the airplane at a different altitude. How many hours will it take the jet to catch up with the airplane? So again, we're going to look at the airplane, and the airplane is flying at 180 miles per hour. So I'm going to multiply that by 180x. My jet is flying at 330 miles per hour, but it's leaving an hour and a half later because to go from noon to 1:30, that's 1.5 hours. So that's x minus 1.5. Now again, I'm going to take the two equations here, set them equal to one another. So I have 180x equals 330 times x minus 1.5. We're going to go ahead and distribute. So I have 180x equals 330x minus 495. I'm going to go ahead and subtract 180x from both sides, which will give me 0 equals 150x minus 495. I'm going to add 495 to both sides, and I end up with 495 equals 150x. So now I'm going to go ahead and divide, and if I divide both sides by 150, I see that x is going to give me 3.3 hours. It says how many hours will it take the jet to catch up to the airplane? It will be 3.3 hours after the airplane left. Okay, or if we look at a time frame, that would be a little after 3 o'clock. Example 7 says Noya drives into the city to buy a software program at a computer store. Because of traffic conditions, she averages only 15 miles per hour. On her drive home, she averages 35 miles per hour. If the total travel time is 2 hours, how long does it take her to drive to the computer store? So we're going to say the first route, okay, it tells us that she averages 15 miles per hour, okay, on her set time of t. On her second route, we're told that she's able to go up to 35 miles an hour. However, we know that we're given a total of 2 hours was her total travel time. So if we know that the first route had t amount of time, then that must mean that our second route was 2 minus t. So just like we've been doing all along, I'm going to take my 15t and set it equal to 35 times 2 minus t, and then I'm going to go ahead and distribute. So I get 15t equals 70 minus 35t. And in this case, because I have a negative t value, I'm going to add 35t to both sides. And we can see that we're going to end up with 50t equals 70. And in order to get t by itself, we need to divide by 50. So I end up with t is going to equal essentially 7/5, which is really 1 2/5 hours, or you could say that's 1.4 hours. And that 1.4 hours is how much time it takes her to get to the software store. Example 8 says, on his way to work from home, your uncle averaged 20 miles per hour. On his drive home, he averaged 40 miles per hour. If the total travel time is an hour and a half, how long did it take for him to drive to work? So again, we have our first half of the drive, which was 20 miles per hour times the number of hours we drove. The second half of the commute, he was able to travel 40 miles per hour, but we know that we only have an hour and a half total drive time, and I'm going to have to subtract the amount of time that we drove for the first round. So I end up with 40 times 1.5 minus h. I'm going to take the two quantities, set them equal to one another. Oops, 1.5 minus h. And again, we're going to distribute. So I have 20h equals 40 times 1.5 will give us 60 minus 40h. I'm going to add 40h to both sides. And I can see that I end up with 60h equals 60 because these cancel. And then I divide both sides by 60. And we see that h is really equal to 1 hour for his drive home from work. Example 9 says Jane and Peter leave their home traveling in opposite directions on a straight road. Peter drives 15 miles an hour faster than Jane. After 3 hours, they're 225 miles apart. We want to find Peter's rate and Jane's rate. So what we can do is we know that it's going to take 3 hours for them to go 225 miles. So I'm going to look at Jane, and then I'm going to go ahead and look at Peter's formulas. So Jane, it's my total time traveled is going to be 3 hours for both of these. What I don't know is the rate in which we travel. So for Jane, I'm going to say that her rate is just r because I don't know what it is. Peter, he's also traveling for 3 hours, but his rate is going to be 15 miles an hour faster. So he's going to be r plus 15. I know that if I add the two of those Jane's and Peter's distances together, they're going to give us our distance of 225. So here I can take my 3t and add, 3r, and add that to 3 times the quantity of r plus 15, and this is going to give me 225 miles. So now I'm going to distribute my 3 into both. So I have 3r plus 3r plus 45 equals 225. I'm going to collect my like terms, or I have 6r plus 45 equals 225. Then I'm going to subtract 45 from both sides, and I have 6r is equal to 180. If we divide both sides by 6, then I see that r is equal to 30 miles per hour. Now it says find Peter's and Jane's rate. So Jane, she's got just the r here, so Jane is going to be 30 miles per hour, while Peter is really going to be 30 plus 15, or 45 miles per hour. Please try to do this real quick by yourself. Here we have Sarah and John. They leave Perryville traveling in opposite directions on a straight road. Sarah travels 12 miles an hour faster than John, and after 2 hours, they're 176 miles apart. So I have Sarah and I have John. Well, John is the slower of the two, and we're both traveling at 2 hours. So I have 2 times, we'll say t for time. Sarah is also going to be traveling 2 hours, but she is going to be 12 miles an hour faster than John. So she's going to be t plus 12. And I know that after 2 hours, they're going to travel a total of 176. So I'm going to have to add these two together. So I have 2t plus 2 times the quantity of t plus 12. These are going to give us 176 miles. So just like we've been doing all along, we're going to distribute first. So I have 2t plus 24 equals 176. Combine your like terms. So I have 4t plus 24 equals 176. We can subtract 24 from both sides, and I have 4t equals 152. Then if I divide both sides by 4, we can see that t is going to equal 38 miles per hour. And so that means John's speed is 38 miles per hour. And Sarah is actually going to be 38 plus 12, or 50 miles per hour. This is the last example of 3-6. Please let me know if you have any questions. Thanks and have a great day.